It's not always convenient to use the definition for the Laplace transformation. So we need to talk about a couple other translations, such as if you had e to the 5t, t cubed, combination of some things we have, or e to the minus 2t, cosine of 4t. Straightforward, provide we could do this. We know the Laplace of t cubed and of the cosine of 4t. And so in general, when you have Laplace of e to the at f of t, we can use a translation or a shifting to transform f of s to f of s minus a, known as the first translation. And here it is again. You have Laplace of f of t equals f of s. First section, where we talked about these. And a is a real number such that e to the at times f of t, then the f idea that we had here from the beginning is translated to f of s minus a. So if you had e to the 5t t cubed, we know that Laplace of t cubed, right, is going to be 3 factorial over s to the 4th. But we're going to translate it now from s to s minus 5, and so it becomes 3 factorial, 6, and then in place of s minus 5 to the 4th power. Or Laplace of e to the 2t cosine of 4t. Again, Laplace of cosine of 4t is s over s squared plus 16. So since e to the minus 2t, a is 2, that means that we're going to go from s to s minus a minus 2, or s plus 2. So it becomes, in place of s plus 2 over s plus 2 squared plus 16. Laplace transformation. So going the other way, if you now have a function of s minus a, Laplace transform is going to be f of s, and then in place of s minus a, and you're going to get e to the at f of t. They become our translations. Becomes the translations. So if we are looking at translating something like this, the first thing we have to do is do the partial fractions on it and get our results. And now we have 2 inverse Laplace of 1 s minus 3, and we have 11 inverse Laplace of 1 over s minus 3 squared. So we know what 1 over s squared is. So this is s minus 1 squared. So this becomes, in place of s, we're going to put the s minus 3. And so we're going to get e to the 3t, that's the a, and 1 over s squared is t. And 2s plus 5 over s minus 3 squared. We're going to have 2, and then s, and when we do that, we get 2e to the 3t over 11e to the 3t times t. And we can now work the transpose out and do the arithmetic on it, and we'll do this one. But the inverse Laplace will allow us to have, in place of s plus 2, so s plus 2 squared, completing the square down here and getting that result, and we can do the inverse Laplace on it. Special translation allows us to do the work. So we have second derivative minus 6, the first derivative, plus 9, the function, t squared e to the 3t. Y of 0 is 2, y prime of 0 is 17. So the Laplace of the second derivative is s squared, the function of s, minus s times y0 minus y prime at 0, minus 6, going to be s, the function of s, minus y0, plus 9, function of s, and then we know what t squared is, right? And a is going to be 3, so it's going to be 2 over s minus 3 cubed. Really 2 factorial, that's why it becomes that. So now we take all the y of s's together, everything that's not y of s, and we now have solved y of s, and now we use the inverse Laplace. We just did these, and we would get our result. So it's a special translation. One other thing in this chapter is what we call a step function, where our function is in steps. So it's 0 from 0 to a, and it's 1 from t going from 0 to t going greater than or equal to a. And it's a step function. And so when we have that kind of a function and we want to use a transpose on it, we're going to use what we're going to call u of t minus a. Broader sense, u t minus a equals 0 for t less than a. That's what that becomes. And so u of t minus a, we now have our result of our function here, and we have step function. So here's the rule. If you have a function, it's a piecewise function. From t going from 0 to a, t going from greater than 0, you have a function of t, and you have h of t. Well then, f of t is the function of g at t minus the function of g at t, u, t minus a, plus the function of h at u, t minus a. And so we can talk about taking a function like this and writing it so that we can have a single term with it. So let me keep that there for just a minute. So f becomes 20t, right? 20t minus 20t u minus a, which in this case is 5, and then it's going to be 0 times u t minus a, so in this case it's 0. So we now have written it as a function so that we can work with trying to solve an equation involving any of that. So the Laplace then of that guy, f of t minus a, u of t minus a, turns out to be e to the minus as function of s. So we can use it to solve a differential equation. Right? You can use it to solve a differential equation. The inverse Laplace then, if we have it in s, e to the minus 2s, right? So that becomes our t minus 2. 1 over s minus 4 is e to the 4. So it's going to be e to the 4t, but t is t minus 2, u of t minus 2. Here our a is minus pi over 2. So it's going to be this is a cosine function. Cosine of 3t, so it's going to be cosine of 3t pi over 2, u of t minus pi over 2. And we can then use that to solve a differential equation when we have a step function. Y prime plus y equals f of t. So the positive y prime is y, a function of s, minus y of 0, and they tell me that y of 0 is 5. So I have that result. And then I have the positive y of s, and then I have this step function, right? This step function, which is going to be 0, minus 0 u t minus pi, and then 3 cosine of u of t minus pi. And we now have these pieces to do. The pos of the cosine is s over s squared plus 1 e to the minus pi t. And so now we can solve the differential equation and then end up back to where we started with the step function. So practice that a little bit, spend some time doing that, and I think you'll find out that it's not really that difficult.